Okay, now since my last recording was kind of a fail, and I know this time I'm actually recording, for question 4, I'm not going to take it long. So we have log 4, it's not an expanded form, so all we have to do is solve for x. So we want to get rid of the log, so you have your x by itself, so you make the log to an exponent of the base, which is 4. Do it on both sides. You get 3x minus 4 equals 64. Because 4 is the exponent. 3 is the exponent of 4, so 4 to the power of 3, 64. Then you want to isolate the 3x by itself. So you add 4 to both sides, you get 3x equals 68. You divide 68 by 3, you get your answer 22.67. That was pretty easy and fast, and I had to write that all over again. Fun! Alright, here we are, our last work problem, everybody. Number 5. Oh. I did not realize I had that still. So I'm just gonna move this for you guys so that won't get in the way. Okay, number 5. So we have another expanded form, and this time we're gonna put it, since it's adding, we know that it will be multiplying. So we're gonna reduce the expanded form to multiplying. So it's gonna be log 5x times x minus 1, I'm gonna write that down, equals 2. Now, as you can notice, there is no log base. Well, if you don't see log base, that means that the log base is divisible, which means it must be 10. So log with no base equals 10. Remember that, okay? So log base of 10, 5x parentheses x minus 1 equals 2. Now you want to get rid of the log, so you do it to the square root. You do 10 on each side, and get rid of, let me get a different color pen. Get rid of these, and then you have 10 to the power of 2, and you end up with your 5x parentheses x minus 1 equals 100. You FOIL that, you end up with 5x squared minus 5x equals 100. And since you're solving for your x, you need to move your 100 so you have it equal to 0, which you can see it's right here. So you have 5x squared minus 5x minus 100 gives you 0. So now there are many ways you can solve for your x, but in this instance we're going to use a quadratic formula. Who doesn't love using that? So we're going back to 8th grade math. Pretty sure that's when I learned it. And here we go. The formula for quadratic formula is x equals negative b plus or minus square root b squared minus 4ac over 2a. And if you go back right here, this is going to be your a. This is your a. This is your b. Don't forget the negative. Don't forget the negative, and this is your c. This 100. Which is a negative 100. Make sure you don't forget your negatives, because then that's going to throw off your whole equation. So the equation is x equals 5 plus or minus square root negative 5 squared minus 4 to the 5, 4 times 5 times negative 100 over 2 times 5. When you solve it all the way, you get x equals 5 plus or minus 45 over 10 after you square root this answer. Then what you do is you do what is called the zero product property. When you place every when you set it up to the zero product property. So 1 will be 5 plus 45 and 5 minus 45, both over 10. And when you solve it, you get x equals 5 and x equals negative 4. Those will be your two x's. And there you go. Those are logarithms for your brain. So now next, we are going to go over a few word problems, and I promise they'll be swift and easy. Okay, so our first word problem is based on affections. Now, there's an affection going around the city where I live in, Lawndale, called annoyingism. It's when a person touches another, talks a certain way, and it annoys the other person, and then they get so annoyed that they start annoying other people. It's very hazardous, and it causes people to kill each other. And I think I might catch it because my brother's annoying me right now. So yeah, if he keeps annoying me, I might have to kill him, and then I'll have to pass it on. All right. So with this little disease that's going around, every day, one person affects 4 people. And I want to know how long it would take for all of the population of Lawndale, which is 135,400 residents, to catch the disease. Now, before we even calculate this, we first have to see what equation will relate the population with the days. So we'll substitute our population with P, and we'll substitute our population with P, and our days with D. Now we already know our population is 135,400 residents, and we want to find out how many days. So what we're first going to do is write down our P, 135,400. We're going to set that equal to, now in total there are 5 people that are infected each day. Because one person that's already affected affects 4, so when they combine, you get your 5 people. So we're going to plug that in. We have 5 people that's infected. We want to know how many days it's going to take. So our D is going to end up being our exponent. And that's how you get your equation. Now, to summarize, we have our population. We want to know how many days. Our days is going to be, and each day, 5 more people will get infected. So it's 5 times 5 times 5 times 5. That's why our D equals our exponent. So our equation is that. Now we're going to solve for how long, for the number of days it'll take for how long to get that. So we take this equation, and we type it down right here. 5. We're going to retype it because that's what we're supposed to do. But it takes forever because this thing doesn't work. And so, since we have this, we are going to use what we've learned before and put this into log formation. With our base being 5 and our population being next to it, we're solving for how many days. Next, since we don't have a base of 10, we are going to put it into log formation where we have our written number over our base. And once we put it in that formation, we're going to take our handy dandy little calculator. Sorry, I'm losing my voice. I gotta finish this soon. So we type it in. Remember, we find our log on our calculator. Log, we type in 135. We type in log 135, 400. And we divide it by log 5. Make sure your parentheses are closed. You can't really see it. Oh yeah, you can see it. Make sure your parentheses are closed. And when you put equal, you get 7.34. And so, hold on for a minute because I'm getting really, really interrupted by my stupid reminders on my computer.